Hi, welcome. In this tutorial, I'll be introducing real-time global illumination in Unity 6. I've already prepared this scene, and it includes elements like lighting and post-processing effects. Now let's select a single light in the scene, which is a directional light. Let's rotate the light using the R key to adjust the shadows. In this scenario, I can't control the indirect lighting or global illumination since this is just a basic light. For instance, in these shadowed areas, I can add additional indirect lights to enhance realism. In previous versions of Unity, we had to configure indirect lighting for each individual light separately. When I select the sun, I can see a section called Indirect Multiplier, which was commonly used in earlier versions. After that, you had to bake the lights, which meant the changes were not real-time. Now to enable real-time GI, I need to incorporate it into a post-processing volume. I currently have a volume with several attributes, but I would rather create a new volume. Don't worry about overlapping the volumes. If you'd like to learn more about volumes in detail, feel free to ask in the comments. Navigate to the Game Object menu and in the Volume section, add a global volume. Next, name the new volume Global Illumination. Now I can drag it under the volume profile game object to create a better organized hierarchy. In the volume component, there is an option called Profile where we can add various attributes. I can also adjust the volume's range. Selecting Global will apply it to the entire scene. Local refers to a specific area, allowing you to create a volume for each distinct section of the scene. The message indicates that you need to add a collider to define the range. I can add a box collider here, and by increasing its size, I can extend the range. Modify the size property. For now, let's set it to global. In the profile section, I can use a pre-made profile by yourself or anyone else. Alternatively, you can click the new button to create a fresh profile. Now let's navigate to the project section and click on profile to see where the profile is saved. This is the location where the profile has been saved. Now let's add attributes by clicking the Add or Write button. In the lighting section, you'll find a post-process option called Screen Space Global Illumination. This is the first post-process I want to use. The second one is the indirect lighting controller, which I will add it later. Turn on the state and set it to enable to activate global illumination. As you can see, the shadows have been adjusted, allowing me to control the lighting. Ensure that GI support is enabled by navigating to the project settings. Within the HDRP, go to lighting settings and make sure that the screen space GI is enabled. If I disable it, a warning message will appear. It is now activated. Activating the tracing option allows you to change the tracing mode. For instance, you can choose ray tracing. Ray tracing relies on the hardware capabilities, such as those from NVIDIA, whereas ray marching uses software tracing. The next option is tier, which allows you to adjust the quality settings. Adjusting the quality will affect the number of samples and various other factors. For instance, the maximum rays have been set to 128, while with lower settings, this number drops to 32. You can manually adjust maximum rays, but setting a value higher than 128 will increase processing load. What I mean is that no noticeable differences will appear. Now let's zoom in on the shadowed areas for a clearer view. The denoise option helps eliminate the noise generated by GI, as it is designed for real-time GI. You can observe the differences. This option reduces the denoise resolution to half, so you might not notice any substantial difference. By adjusting the denoiser radius, you can control its effect, but you might not see a noticeable difference. It's important to adjust the denoiser settings carefully, as they have a minimal visual impact. The next option is the second denoiser, which will assist the main denoiser in working better in certain areas. In my scene, its effect is minimal. The full resolution option pertains to global illumination. When I disable it, I notice some flickering. The remaining fields are less important than the others, so we'll skip over them. The next attribute allows us to adjust the intensity of GI. Navigate to the lighting section and add the indirect lighting controller. There are several fields available. Let's begin with Indirect Diffuse. This will adjust the intensity of the primary indirect lighting effect. Setting a low value will result in stronger shadows. The default intensity is set to 1. Let's adjust it to a value of 1.2, for example. Great, it's working for now. The next option specifies which channels will support this intensity. For instance, if you set it to nothing, none of the objects will respond to the intensity value. For instance, you can assign light layer 1 to the tree, and then select this layer here to apply the intensity exclusively to the trees. This value controls the intensity of the specular reflection, and you can choose which objects will be affected by it. I'll choose a low value for this field because I don't want excessive shininess in this scene. The next option specifies which layers will adhere to the specular intensity setting. This option functions the same way as the previous layer option. The final option is similar to the specular reflection, but it specifically affects the reflection probes. The previous option affects the reflections of the sky and so on. Alright, this is the final result. You'll need to adjust attributes according to your needs. However, incorporating this post-processing is crucial for achieving realistic results. Thanks for watching. If you enjoyed this video, please give it a like and don't forget to subscribe to the channel. And feel free to share your questions and ideas in the comments.